On this example, you're an ice cream maker and decide that ice cream with a 9% butterfat is the best to sell. How many gallons of ice cream with 5% butterfat should be mixed with ice cream that has 15% butterfat to make 200 gallons of the desired blend? Alright, so this is another mixture problem because we're actually mixing two things together. And our rate here is, you can see, the percent butterfat. This is probably going to be, I'm guessing, gallons of pure butterfat per gallons of total volume. So setting up our rate here, I'm going to just go ahead and call this a concentration, and our concentration times the total volume is equal to the pure butterfat. And again, I'm getting these formulas. I'm figuring this out because this concentration makes sense that it would be pure butterfat per total volume. So when I multiply by total volume, I would get pure butterfat. So, I'm kind of reading that all off of just interpreting what that rate says. Alright, so I'm mixing 5% with 15%, and my total here, I want to be 9% butterfat. So 0.09, should be 0.15, and this should be 0.05. Again, whenever I'm writing any percents down, I want to write them as a decimal, rather than keeping that percent symbol in there, because that'll just mess up where my decimal place should be. Let's see. I know that there should be 200 gallons of the desired blend, so the total volume here of this mix is 200 gallons. And I have two of the three parts of this bottom formula, so I can go ahead and multiply these together to figure out what the amount of pure butterfat here is. So 0.09 times 200 gives me 18. So there's 18 gallons of pure butterfat. Okay, and that looks like all of the numbers that I can pull from up above. I need to throw some variables in here, and I'm going to make them these variables right here. We get 0.05x and 0.15y when I use my formulas there, and my equations are those equations right there. So I get x plus y equals 200, and 0.05x plus 0.15y equals 18. And you can see each of these equations. This one speaks to, you can see that equation was pulled from the total volume column. This is all talking about volumes. X would be a number of gallons of 5% ice cream. Y is the number of gallons of 15% ice cream. 200, that's the number of gallons of the mix. This 0.05x, that's the amount of butterfat we get from the first. This is the amount of butterfat we get from the second. This is the amount of butterfat that we want. So those equations really are saying something in each individually, and also the units line up. To solve this, I'd like to get rid of those decimals. I guess it's not necessary. I think I did one using substitution. I'm going to stick with the elimination method because I just think it tends to work a little nicer for a lot of these. Or, yeah, I'm going to eat those words. I disagree. I'm going to go with the substitution method. So this first equation I can solve for either x or y. Either one is just as easily. If my memory serves, I solved one for x already, so I'm going to solve this for y. And I'm not really using any grand strategy there. I'm just kind of saying these both have a coefficient of 1. They're both just as valid choices as the other. So x plus y equals 200. When I solve that for y, I want to subtract x from both sides. To get rid of the x, I get y equals 200 minus x. And since that value that's what y is, I can plug that into the location of y in the other equation. So this gives me 0.05x plus 0.15 times whatever y was equals 18. And the value of y was 200 minus x. So distributing my 0.15 through the parentheses, I get 0.05x plus, well, 0.15 times 200 is 30. When I combine like terms, the 0.15x and the 0.05x and the negative 0.15x gives me a negative 0.10x, or just 0.1x. Subtracting 30 from both sides, I get negative 0.1x equals negative 12, because I subtracted 30 from here and 30 from there. Those cancel. I get negative 12 on the right-hand side. Dividing both sides by negative 0.1, it's the same as multiplying by negative 10, so I get x equals 120. X was, what did x represent? The number of gallons of 5% ice cream, 5% in butterfat, that is. So we just need to find y, and since x plus y equals 200, that gives us 120 plus y equals 200. Subtract 120 from both sides, we get y equals 80. So we want 120 gallons of 5% butterfat and 80 gallons of 15%. Let's think about if this makes sense. Obviously, I could do the normal checks. I could make sure that they sum up to 200. Clearly they do. I could also make sure that I have the correct amount of butterfat. I'm going to go ahead and skip past those. I'm just, like I said, I'm going to think about if this logically makes sense. We're trying to figure out, we want to get ultimately the amount of butterfat we want to be almost equal between the two of them. Almost right in the middle. If we were going for 10% butterfat, then we'd have just as much 5% as 15%, because we'd want to average them exactly. But because I want this to be slightly less than 10%, that means I need to have slightly more 5% ice cream than 15. So I'm doing a little bit more of the lower concentration. And you can see that that's actually what ends up happening here. 120 gallons of 5% and 80 gallons of 15%. Slightly more than half of it is the 5%, and so we end up with a concentration that's slightly under that halfway point, that 10%. It's actually down to 9%.